Hello my dears, how are you all? So for 2-3 days I couldn't take class because I was in my village, my hometown. So it is actually a rural area, so network problem was there, so I couldn't upload video. Okay, and also I couldn't take because these setups were this studio setup was not there, right? So anyway, we will continue. So now today we are going to discuss a very important session, control system, that is nothing but Routh's stability criteria. It's a very important session, my dear. A sure short question you can expect from this. A sure short question you can express from this. Okay, so what is this Routh's stability criteria means? It is a method to determine the stability of a closed loop system. Here we are using the transfer function in order to predict the stability of the system. We are using the characteristic equation of the transfer function. So what is the characteristic equation? We know that suppose the transfer function is nothing but T of s equal to G of s divided by 1 plus G of s into H of s, right? It's a closed loop with negative feedback system, right? So characteristic equation is nothing but, my dears, this equal to 0 is called the characteristic equation. So that is called G of s divided by Q of s. This Q of s is called the characteristics equation. So in Routh stability criteria, we are utilizing the characteristic equation in order to predict the stability of the system. Okay, so let us write some rules in order to make the point very clear. So we are using what is the method actually? So first step is make RH table. Okay, it is actually Hurwitz criteria. Hurwitz actually full name. Short form it is Routh stability criteria, but Hurwitz is the full name. Okay, so that is why Routh Hurwitz table. That is the first step of doing the Routh stability criteria. So what is the next step? So next step is nothing but, my dear, if all the signs of first column of a Routh Hurwitz table, or simply RH table is same, then the closed loop system is stable. If there is any sign change, in first column, then the system is unstable. And number of sign change equal to number of RHS poles. I will explain after writing completely. Okay, and fourth rule, if R of z, that is nothing but row of zeros, occurs, then the system is marginally stable. Short formly MS, marginally stable. Fifth rule, if R of z, that is nothing but row of 0, right, occurs, then imaginary root can occurs. can occurs. So my dear, these are the very important rules for determining. I will not completely, but very important rule. So the complete rule now that will be only what projected when we are doing a problem. Okay, otherwise that will be more and more complicated. If I wrote complete theory regarding the step-by procedure and all, you will simply your head will start ache. Okay, so that's why I simply representing these these 5 points in front of you. First one, the first step is make Routh Hurwitz table. That I will tell you how it will form. So what is the main rule of this Routh stability criteria? What is the benefit of this in order to predict the stability of a closed loop system? Okay, and if all the signs of the first column of Routh table, then there is a Routh table is same, then the closed loop system is stable. That means that I will discuss later. The Routh stability criteria. After that we will form so many columns. Okay, and the first column, there is no sign change in the first column, then the system will be stable. I will explain. Okay, don't worry. If there is any sign change in the first column, then the system is unstable. If there is any changes in the first column, for example, suppose the column contains 5, 3, 2, 1, which means they all are positive. All are positive, which means there is no sign change. Suppose this contains -2 means there is how many sign changes there? 2 sign changes are there. First one, from plus to minus a change, plus minus to plus another change. So this is first change, so this is second change. So there are 2 changes in the first column. That is the meaning of change. Okay, that is the meaning of what first column change. Is it clear, my dears? And see one more thing. What is that? If rows of 0 occurs, then the system is marginally stable. That means I will explain. In the column now, so many columns are there, my dears, in the Routh stability criteria analysis or RH table. Suppose these some rows contain full zeros, then we can definitely say that the system is marginally stable. The system is marginally stable means what, my dears? The system is marginally stable means what? There is imaginary roots that I already explained. There are roots on the imaginary axis. Then we can say that there is a marginal stability. Okay, there is a marginal stability. If RZ occurs, then imaginary roots can occur. Okay, so let us do this concept with an example so that you will be thoroughly understand what it is exactly. Okay. You will thoroughly understand what it is exactly. Write a problem ideas so that you will be able to understand what exactly the concept is. You will be able to understand what exactly the concept is. Write a question. Q of S is equal to S cube plus 4S square plus 8S plus 2. Okay. So Q of S means check whether the system is stable or not. Check whether the system is stable or not. So this is the question, my dear. So how can we form the RH table? That is the important thing you have to note down. So how can we form the RH table, my dears? Listen. So for forming the RH table, start from the highest degree. It is 3 now. It is 3 now. So I can write like S cube, S square, S raised to 1, S raised to 0. Okay. Like this. Is it clear? And write like this. For S cube, the coefficient is 1. I mean, chode the next term. And chode means you just Q to the next term and focus the next term. So 8. Is it clear? Is it clear? And First term, leave the second term, focus on next term. Again leave the second term, focus on next. Focus on next means nothing there, so it will be 0. Alternatively, you have to write the coefficients. That is the important thing. First I wrote the coefficient of 1 into s cube, so 1. Next I left the second term, right? I left the second term and I goes to the third term alternatively. First one and third one, again fifth one. If there is no fifth one, means simply 0. If there is no fifth one, means 1, my dear. It is simply 0. No need to focus. Okay. And next row is, my dear, start from the s square term. S square is nothing but 4. So 4. Leave the second term. Next go to other term 2. And leave the other term. It's nothing there. So it is simply 0. Simply 0. And s raised to 1. S raised to 1 means what? Is there is any s term? 4, 2, 0. S, finish. Everything is there. Everything is there. Okay. So you see, 1 is there, 4 is there, 8 is there, 2 is there. Everything you got. Everything is finished. Everything is finished. Okay. And the remaining rows now, my dear, the remaining rows that you have to calculate. So these row you have to calculate and these row you have to calculate. Then only the first column will complete, correct? This row you have to calculate, these row you have to calculate, then only the first column will complete. Okay, so first you wrote this, and what is this element? What is this element? For understand, for what? Finding this element, just go the top side, just open, just above this unknown. This is the unknown. Just above this unknown, focus on this number. Okay, multiply this with this, multiply this with this, divide by this. Okay, that means nothing but, my dear, 4 into 8 minus 1 into 2 divided by 4, which is nothing but what? 32 minus 2 by 4, 30 by 4, 15 by 2, which is nothing but 7.5, which is nothing but what, my dear? 7.5. Okay, so write it, 7.5, 7.5. Okay, and the next term now, my dears, next term now, 4 into 0 minus 1 into 0 divided by 4. Next term is this term. This term means this into this minus again this into this divided by this. You focus on this only. Okay, so this into 0 means 0, this into 0 means again 0. 0, nothing. Is it clear? And the below row. So for finding the below row, my dears, just to focus on the upper row. This is the unknown, just to focus on the upper row. What is that? 7.5. So it will be this into this minus this into this divided by 7.5, which is nothing but, my dear, 7.5 into 2 minus 4 into 0 na? 4 into 0 4 divided by 7.5, simply 2, my dear, simply 2. Is it clear? Is it clear? And 7.5 into 0 and nothing there is 0, 0. It is 0, 0. It is 0, 0. Is it correct? Is it correct? You got this? You got this, my dears? Okay. Okay, so that's all. Is it clear? this into this 715, and 15 divided by 7.5, it is nothing but 272. So you got the answer. Okay my dear, this into this divided by this one. Is it clear? See the first column, focus on the first column. Is there is any sign change? Is there is any sign change my dears? All are positives. So you can conclude like, in the first column there is no sign change. So the given system is stable, which means all the roots or poles lies on LHS of S-plane. That is the meaning of stability. What I already told you, if a system is unstable means, my dear, any one pole is locating on the right side of the S-plane, then we can say that it is unstable system. If all the poles lies on the left half side of the S-plane, then we can say that it's a stable system. So this system is what? Stable. This system is stable. So all the roots, nothing but 3 roots. I can say that. Okay. Number of LHS roots will be, or poles will be equal to what, my dear? 3. Because it's a third degree equation, right? S cube means third degree equation. So there will be 3 solutions. It implies the solution of this equation will definitely give you the number of poles. Am I right? Q of S equal to 0 will give you the number of poles, not the 0. So it give you the number of poles, and S cube means there are 3 number of poles after solving this characteristic equation. If you solve this characteristic equation, you will get, for S is equal to 3 value, you will get 3 value. These 3 values now, it each implies the poles. These 3 values implies the pole, that means 3 poles. These 3 poles are locating on the LHS of the S plane. Because the system is stable. There is no sign change. So this is how you have to solve for RH table. Is it clear, my dear? Is it clear? Okay. Can we go for next question? Write a question, my dears. QF is equal to QFS mean what? Characteristic equation. 4S cube plus S square plus 2S plus 8. So now you have to find the same thing. You have to draw the RH table first. So how can we draw the RH table? Start from S cube now. So S cube, S square, S raised to 1, S raised to 0. Okay. Start a row like this. So 4 alternatingly 2. Nothing now. 0. Next one for this. Start from the second. 1 alternatingly 8, 0. Okay. Always make a 3 column arrangement. Then it will be very easy, right? And for this you have to find out, and this is will be nothing but just to focus on the top side of the row, my dears. This is the number. Focus on this into this minus this into this divided by this. Okay, we will find that 1 into 2 minus 8 into 4 whole divided by 1. So it will be 2 minus 32 1. So minus 30. So what is that, my dears? Minus 30. Okay. So minus 30. You got it as minus 30. And next one, this into 0. This into 0 minus this into this divided by this. This into 0, this into 0, everything is 0. 0. Okay. And find this row also. So for that, focus on this. This into this minus this into this, my dear, divided by this. So this into this means minus 30 into 8 minus 1 into 0 all divided by what? Minus 30. Correct now? So minus and minus got done, simply 8 will be the answer. 8. This into 0 minus this into 0 divided by this means simply 0. 0. Okay? Did you get this, my dears? Did you get this? So see the nature here. Number of sign change, I will write like number of sign change in the first column equal to how many sign changes are there, my dears? From here to here means plus to minus 1 sign change, and from here to here means again minus to plus second sign change. So there are how many sign changes, my dears? So there are how many sign changes, my dear? There are 2 sign change in the first column. So it will be 2. So what was we wrote in the what steps for rules in the RH stability criteria we already write now. The number of sign change is equal to number of roots or simply poles. I can write like simply number of poles on RHS of S-plane equal to number of sign changes. So it will be 2. So it will be what? Number of poles on RHS of S-plane will be equal to 2. So what it means, my dear? There are see number of poles on LHS will be equal to what? For S cube means it is third degree equation, right? It's a third degree equation. So definitely what? 2 poles are already we found the idea of 2 poles. It is on the right side of S plane. So definitely one pole is also there now, because S cube means 3 poles will be there. 2 poles you already concluded it is on the right side of the what? S plane. So 1 pole will be where what? LHS. So number of poles on LHS will be what, my dear? 1. Because the total poles will be equal to what? 3. 2 plus 1 equal to 3. Okay. So since 2 poles on RHS of S plane, the system is what, my dear? The system is stable or unstable? The system is unstable. The system is unstable. See, these type of question you may expect for your examination. Very big questions or more than 1 minute taking question, you will not expect that type of question, my dear. You just expect this type of question because it is just a 2-3 line and you have to think a little and you will get an answer. So these type of question you may expect. Find the stability of the given transfer function or simply the characteristic equation. That you can expect. That you can expect. Is it clear, my dears? Is it clear? Okay. Okay. Write another question. Write another question. I will try to do maximum questions, my dears. Okay. I mean not the same pattern but different pattern, so that any one of the pattern will be asked for exam. Okay. Write another question, my dears. Q of S is equal to S cube plus 4s square plus 2s plus 8. And how can we find the stability? Okay, you have to find again the stability values. Okay, listen. So write again the root table are s cube, s2, s raised to 1, s raised to 0. Am I right? So write it. This coefficient is nothing but 1 into s cube, correct? Now 1 into s cube, so it will be 1. So 1, alternatively 2. Okay, 0 if you want 0. Next row, this one and next to this one. So it is simply 4, 8 and 0. Everything you complete, right? So you are going to make the third row. So how can we make the third row? This is the unknown here. Focus on this one. Okay, so this into this minus this into this one. So it will become 4 into 2 minus 1 into 8 divided by 4. So it will become something but 8 minus 8 by 4. Something but, my dear, 0. So this element is something but 0. And this element is nothing but, my dear, this into this minus this into this divided by this. This into this again 0. This into this again 0 divided by 4 means 0. So 0 and 0. Now you observe one thing, my dear. You observe one thing. There is a row of 0. There is a row of 0 because this row completely 0. This row completely 0. If this case arises while solving, then one alternative method also you have to utilize. Just focus on the upper row. I mean just above row you have to focus. Write the auxiliary equation for that row. Write the auxiliary equation for that. I will write now. If R of Z occurs, write the auxiliary equation focusing by focusing just above row. So what you have to do now? If the R of Z, that is rows of zeros occur, what you have to do, my dears? You have to go for the auxiliary equation. And how can we create the auxiliary equation? Just focus on the row just above this R of Z. The row above this is nothing but 4, 8 and 0. 4, 8 and 0. And you have to make the characteristic equation in such a manner that I will tell you, my dear. Let A of S be the characteristic equation. And A of S is nothing but, my dear, 4s square plus 8s raised to 0. I mean 2 power lessons. Same manner, my dear. Here you leave one and now this leave the next and write the next, again next and leave the next and write, right? So this lab. So the same manner, this is 4s square. So the next power will be 1 chodkar next. You just leave one and take the next. So 4s square not plus 8s but 8s raised to 0. S raised to 0 is nothing but, my dear, 1. S raised to 0 is nothing but 1. So this will be the auxiliary equation. This will be the auxiliary equation. And just to solve this auxiliary equation, my dears, A of S equal to 0. Just to solve this, which implies what? 4s square plus 8 is equal to 0, or s square plus 2 equal to 0, or s square equal to minus 2, or s is equal to plus or minus this s square equal to minus 2 you can write like what? S square equal to this minus 1 into 2, correct? Now this can be minus 1. What is that, my dear? Minus 1 is nothing but j square, correct? Because j are equal to root of minus 1. So symbol minus 1 I can write like j square. Am I right? Because I will write in the j is equal to root of minus 1. Okay, this is the reason. So minus 1 into 2 I can write like simply j square into 2. So what will be s, my dears? S. It's nothing but plus or minus j root 2. S will be what, my dears? Plus or minus j root 2. Okay. S or minus plus or minus s is equal to plus or minus j root 2. The solution of the characteristic equation implies that, my dear, there are two roots in the imaginary axis. S is equal to plus or minus j root 2 means the nature of the root will be like this, sigma and j omega axis, and here one root and here one, here minus j root 2 and here plus j root 2. So we got an idea about two roots or two poles of the characteristic equation or the system. Total there are three roots, my dear, or three poles of the characteristic equation are there, and by solving the auxiliary equation we got an idea about two poles. One is on j root 2 and another one is on minus j root 2, and the remaining one pole, that everywhere that can be everywhere. That is not our concern, because we just want to check the stability. I will tell you, and we have to forward further now. We have to forward further now. This row also we have to calculate. We just here now we got all zeros. So what we did, we worked the auxiliary equation, solve the auxiliary equation. We got the idea about where will be two poles, okay, but nothing about this row now. Okay, again what we have to do? What we have to do, my dears? So for that we have our a of s. What a of s is? What, my dear? 4s square plus 8. Okay, now d by ds of a of s you have to find. What will be d by ds of a raised to s? 8s plus 0, correct now? Or simply 8s, simply 8s. Remove the zeros by the derivative of the auxiliary equation. What we have to do? Remove or replace r of z with dfs by ds. That means this 0 now, my dear, first 0, it is 8s now. So s raised to 1 is correctly 8. Nothing is there now, so simply 0 and simply 0. So you replaced this 0 with the 8, you replaced this 0 with the new 0, you replaced this 0 with the new 0. Now an element is here, my dears, so that you can go for the next row. The problem for not going to this row is that there is all rows, all row contain, the row full contain zeros. That was the problem. Now the problem eliminated. We got a number there, so that we can easily go for the next row. So what is the next row? This is the unknown. Focus on this into this minus this into this divided by this. It will be what? 8 into 8 minus 4 into 0 divided by 8, simply 8. So this row will be again 8, and this one, this into this minus this into this divided by 0, so 0 and 0. Is it clear? Is it clear, my dears? Is that clear? Okay? If there is any doubt? If there is any doubt, my dears? Okay? Okay? So what you get finally? You got finally first column contain 1, 4, 8, 8. Is there is any sign change? Is there is any sign change on the first column? No. There is no sign change on the first column, yes. Which means number of sign change on first column equal to 0. If there is no sign change on the first column, my dears, what it implies? What it implies? Number of poles on RHS equal to 0, which means the system is stable. Which means the system is stable. System is stable. Is it clear? Is it clear, my dears? There is no sign change in the first column. So by simply removing our eyes, by simply closing our eyes, we can say that the system is stable. The system is stable. Is it clear, my dears? If there is any doubt, you can ask. And one more thing you have to know now, there are what? There are one more thing, my dear, one more thing. The system is marginally stable, my dear. Marginally stable, not stable, marginally stable. Why means, I already explained in the rules, I mean the determining rules for the stability, that if there is any poles on the imaginary axis, my dears, what happens? The system will be marginally stable. So that number of poles on RHS equal to 0, but you add one more line, 0, but 2 poles on imaginary axis makes the system marginally stable. Make the system what, my dears? Marginally stable, MS. Because 2 poles are on the imaginary axis. 1 pole of course on LHS, my dear, because it contains total 3 poles. So 2 poles already on the imaginary axis, 1 pole is only on LHS, because there is no poles on the RHS. So already 2 is on imaginary, so only possibility for the next pole is on RHS now. Sorry, LHS now. There are 3 poles only. 2 poles you already plotted on imaginary axis. There is no poles on the RHS. So what is the only possibility for the remaining 1 pole? It should be on the LHS. It should be on the LHS. Correct? Correct. So the system will be marginally stable, my dears. The system will be marginally stable. Is that clear? Is that clear, my dears? Okay. Can we go for next question? I am little fast because you have to complete a lot, my dears. You have to complete a lot. If you have any doubt, you can rewind the video and you can watch, or you can adjust your speed to 0.5x or something like that. You can easily grab it. Okay, but we have to move faster. Write another question, my dears. Q of S will be equal to 5s raised to 5, 4s raised to 4, 3s cube, 2s square, s plus 1. Okay. So now you have to again find the stability. No need to write it all now. Find the stability. How can we know that? Again, sure. Okay, write another question, my dears. So in between there was some error. Okay, so write another question. So 5s raised to 5 plus 4s raised to 4 plus 3s cube plus 2s square plus s equal plus 1. So what you have to find again the stability. Okay, how can we find? Write the Routh array. S raised to 5, S raised to 4, S cube, 0. So it will be 5, alternatively 3, alternatively 1. Correct na? Coefficients 5, 3 and 1. Next 4, alternatively 2, alternatively 1. Everything you got completed, right? So you have to find the remaining all rows. That is the last task. That is the real task, my dear. That is the real task. Okay. How can we go further? Find this two. For finding this unknown, focus on this. This into this minus this into this divided by this. So what it will be? 4 into 3 minus 5 into 2 whole divided by 4. So it will become 12 minus 10 by 4. It is nothing but, my dear, 2 by 4. It is nothing but 1 by 2. 0.5. Correct? Correct now? For finding this number, just this into this minus this into this divided by this one. So it will become 4 into 1 minus 5 into 1 whole divided by 4. Minus 1 by 4. Correct now? So it will become minus 1 by 4. For finding this number, there is nothing, my dear. This is 0. So simple 0. So you got this row, right? Again, you have to calculate this row also. So for finding this unknown, focus on this. This into this minus this into this all by this. So it will become 0.5 into 2 minus 1.1 by 4 into 4 whole divided by 0.5. So it will become 1 minus 1 divided by 1 plus 1 divided by 0.5. So it is nothing but, my dear, 2 by 0.5 is nothing but 4. So now you got 4. So for this unknown, this into this minus this into this divided by this. So this into this means 0.5 into 1 minus 0 divided by 0.5 is simply 1. And there is no 1, 0. And for this, focus on this. This into this minus this into 0 divided by 4. So it become, I will find it, 4 into minus 1 by 4 minus 0.5 whole divided by 4. So it will become minus 1.5 by 4. So write that minus 1.5 by 4. Okay. For finding this element, this into this minus this into this by this 0 and 0. Because this into this means 0, this into this means again 0. Last row you have to find. For this element, focus on this. This into this minus this into this divided by 0. So this into this 1. 1 into minus 0.1, 1.5 by 4 minus 0 by again this number. So the result will be 1. No need to calculate, right? And for this element, this into 0 minus this into 0 by again 0 and 0. Now, what is the conclusion from this Routh table? What is the conclusion from this Routh table? We can put number of poles on RHS will be equal to what, my dear? Number of sign change. Plus, array minus. Focus on the minus. Just go focus on top and just focus on bottom. So from plus to minus, my dear, one sign change. From this minus to this plus, again one sign change. So there will be two sign change. So number of poles on RHS will be equal to 2. And the number of poles on RHS will be equal to 2. So how can you write number of poles on LHS? What will be number of poles on LHS, my dear? Total there are 5 roots or 5 poles of this characteristic equation, because s raised to 5 is a 5 degree or 5 order, 5th order characteristic equation, correct? 5th order characteristic equation. Or number of poles on LHS will be equal to what? 3, because 2 plus 3 will be equal to 5, simple. So the system is unstable because there are what, my dear, 2 poles on the RHS. If any one pole lies on the RHS of the characteristic, S-plane, my dear, S-plane, then the system will be what? Unstable. Then the system will be what? Unstable. Is it clear? Is everything clear, my dears? Is everything clear? Can I rub this? Okay. Can we do another problem? Simply S raised to 5. Okay. S raised to 6 plus S raised to 5 plus 5 S raised to 4 plus 3S cube plus 2S square minus 4S minus 8. Okay. Okay, my dears. How can we solve this? How can we solve this? Again, you have to form the what? RH table, right? So, can we know the RH table? S raised to 6, S raised to 5, S raised to 4, S cube, S raised to 0. Okay, so what is that? Alternatively, 1, 5, 2, minus 8. Am I correct, my dears? And next one, 1, 3, minus 4, 0. Bas, everything you got. Next you have to find the remainders. Okay. For this, what we have to do, my dears? Focus on this into this, minus this into this. Correct now? So it will become 1 into 5 minus 1 into 3 whole divided by 1. So it will be 5 minus 3, 2. So it will be 2. For this element, this into this minus this into this. Correct now? So it will become 1 into 2 minus 1 into minus 4. Am I right, my dear? Minus 4 divided by 1. So it will become 1 into 2 or simply 2, my dears. 2 plus 4. 6. 6. For finding this element, this into this minus this into 0 divided by this. So 1 into minus 8 divided by 1. Correct now? So simply minus 8. Remaining is nothing, so it will be 0. Okay? 6, 2, 6 minus 8, 0. 2, 6 minus 8, 0. Okay? And what will be the next one, my dears? What will be the next one? Oh, sorry, my dear, sorry. I made a mistake. Nothing. Just okay, that's all. Just I rearrange, I mean the term I missed here, right? That's all. So it will be S raised to 4 term, 2, 6 minus 8 and 0. Correct now? 2, 6 minus 8 and 0. Next you have to find this element. How can we find this element? Focus on this into this minus this into this by this. So it will become 2 into 3 minus 1 into 6 by 2. 6 minus 6 by 2 is equal to 0. This term, this into this minus this into this. So it will be minus 8 plus 8. Minus 8 plus 8. So again 0. And for this element, this into this minus this into this. So it will become again 0 now. Simply 0. Everything will be 0. So there is R offset happens. See, my dears, you have to note one thing. All the time this R of Z, it will be odd powers of S will happen only. It will happen only on the odd powers of s. Either in s raised to 5, it will be very rare for s raised to 5. Either in s raised to 3, other chance is s raised to 1. So the odd power of s will always carry the r of z, my dears. Always carries the r of s. That you have to note. The odd powers of s will always carries the r of z. That you have to note. So this forms the r of z, my dears. So what we have to do? If there is r of z, means you have to go for auxiliary equation. So what is auxiliary equation, my dear? A of s. Just go for the top, I mean just above rho. This is nothing but 2s raised to 4 plus 6s square minus 8 equal to 0. So this is what? Auxiliary equation. What is d by ds of s? Auxiliary equation. 8s cube plus 12s, correct na? 8s cube plus 12s. So replace that zeros with the derivative of auxiliary equation, okay, which is nothing but, my dear, 8, replace that with 8 and 12. Again, there is 0, zeros, it is old and new are same. So now this row containing 8, 12, 0, 0. So that you can go for the next row, no issue. So for this element, focus on this 8, this into this, minus this into this by this. Which means what? Which means what, my dear? 8 into 6 minus 2 into 12. Correct na? Divided by 8. So it is 48 minus 24 by 8. So 24 by 8 is nothing but 3. Correct, my dears? So 3. So this row, first element 3. And for next row, this into this minus this into this, my dear. So this into this means minus 8 divided by again 8 means what? 8 into minus 8 divided by 8. What is that? Minus 8. Because this into this minus this into 0 na, so no need to focus on that. And for the remaining, this again 0, correct? So 0. So you got the s square row also, right? S square 3 minus 8 0 0. And the next row, my dears, and the next row, what is that? For this element, focus on this into this, minus this into this by this. So it will become 3 into 12, correct na? 3 into 12 minus 8 into minus 8, correct? Divided by 3. So 36 plus 64 divided by 3. 100 by 3. Correct, my dears? 100 by 3. So I can write here 100 by 3. Okay, and for the next element, this into this 0 and this into this 0 again 0 0 0. Okay, so 100 by 3 0 0 0. Next last term, my dear. For this element, this into this minus this into 0. Correct? So simply this into this. So minus 800. 100 by 3 into minus 8 divided by 100 by 3 will become simply minus 8. Okay. Okay, my dears. Okay. So can you tell me number of poles on RHS equal to what, my dear? Number of sign change. How many sign changes are here? Just from this to this only one sign change. Bottom no number. So symbol simply plus to minus only one sign change. So 1. If there is any one pole on the RHS, my dear, the system is unstable. The system is unstable. And by solving this A of s equal to 0, you will get what? You will get the number of poles on the imaginary axis. Okay, let's solve that. A of s equal to 0 implies 2s raised to 4 plus 6s square minus 8 equal to 0. Put s square equal to x, my dear. For simplicity, I am doing this for simplicity. put x square equal to x. So this equation will become 2x square y plus 6x minus 8 equal to 0. So x will be equal to minus 6 plus or minus root of 36 minus 4 into 2 into 8 minus 8. So it will become plus 8 whole divided by 4. So again simplify now. Again you can simplify this. Again you can simplify this one. By taking 2 outside, it will become x square plus 3x minus 4 equal to 0. And x will become minus 3 plus or minus root of b square 9 plus 4 into 4. Correct na? 4 AC na? So it will be 1. So it will become minus 3 plus or minus 4 into 4, 16 plus 9, 25. So simplify by 2. 1 into 2 na? 2a na? So by 2. So it will become minus 3 minus 5 by 2 minus 4 or x equal to minus 3 plus 5 by 2 which is equal to what? 1. Okay my dear, which implies x is equal to what my dear? S square. So s square equal to minus 4, which is nothing minus 1 into 4, which is nothing but j square into 4. So s will be simply equal to what my dear? Plus or minus j2. Plus or minus j2. Correct na? Correct na? For this one, this is for this. For this one, s square equal to 1 means s is equal to plus or minus 1. Correct na? Because we already substituted x. S square equal to x na? X na? So it will become s square equal to 1. So s equal to plus or minus 1. So now you have my dear 2 roots on the imaginary axis. Correct? 2 roots on the imaginary axis and one again 2 roots on the what? LHS. So you can write finally, final step you can write my dear. First step here, right here. The question may be from here also. You can write here. Number of poles on LHS will be what my dear? LHS will be 2. Sorry, 1. No, this 1 is there. 1 is there now. Just to draw this my dear, just to draw this. After that you can write. Just to draw these poles. 1 is here, 1 is here. J2 minus J2. Plus 1 is here, minus 1 is here, and plus 1 is here. So now number of roots on the RHS you already 1, that is already we have. For imaginary roots you can write like number of roots or simply poles on imaginary axis equal to what? 2. Next, number of poles on LHS will be what my dear? Total you have 6 poles now. So 6 minus of 2 poles on the imaginary axis, 1 pole already on the RHS. So the remaining will be 3. So number of poles on LHS will be 3. Any question from this may ask my dear. Any question from this may ask, because this is that much important. This is that much important. It's that much important my dears. Is it clear? Is it clear my dears? Is it clear? Okay, so that's all for today my dear. So since it's very late now, almost 11:30 PM now, okay, so let's continue from tomorrow. Okay, that's all for today. Thank you so much my dear.